You get it? Great donuts.
Oh, yeah. Last chance to grab some pizza. Guys in the back, feel free to come join us up at the front. It's going to be fun. Yeah, exactly. We don't throw, we don't spit. We're nice. Yeah.
Hi, let's get started. We have our invited speakers from MapD and Nvidia. They're giving us a talk in our meetup group. So, hand of applause for them. And also for MapD, they're doing our sponsorship for this meetup. And before we go into the detail, just a little bit reminder as a regular steps. We have following meetups coming up. July 11th, we have the MLDL study group that we're starting. We had good traction last meetup, so we'll see how it goes. We have set a specific goal to go through what we need to study, so that's a good step. The one next is July 31st. CEO Amir Hussain from Spark Cognition. He'll be doing a book reading from his book, and that should be interesting, so please stay tuned. Our sponsors and partner for this meetup, Capital Factory providing the venue, MapD, they're sponsoring our food and speakers, and we have our regular announcements like a lightning talk section. If you wanna do any kind of lightning talk, 5-10 minutes, please contact me anytime. We can set you up for the next meetup. Slack channel, we started one, and MLD study group, as I stated. And as usual, we have a non-profit set up to move this even more forward with this meetup group, and also interested people trying to get to do something good for the community. With that, invited speakers, Alex is from Nvidia, very much. Did I get it?
No, you're good.
Yeah.
Just being a goofball.
Yeah. Yeah, no, I'm just kidding. But he is definitely the man to talk about the Nvidia GPU, what they're doing there, really deep down, and has cool stuff to talk about. And then our next speaker, Aaron from AVP and MapD, he's going to talk about all those cool things they're doing with GPU, but a lot of big data. So we'll see how it works out. So with that, we'll request the first speaker.
All right, sure.
All right. So
Steve Davis is here from MapD as well. So
oh, okay.
I'm your local guy, just for MapD. Just wanted to introduce myself.
Cool.
Do a quick switch over.
All right.
And this one.
Much better screen.
Start this one. Should be good.
Excellent. I have all the tools. You ready?
Ready.
Great. So I'm Sabatier. I live here in Austin, as you can tell by my accent. It's very East Austin. Very East. I'm French, but I landed here in Austin at Nvidia, and it's a great place to work. It's a fantastic company. There is an explosion of creativity. I think that everybody here probably heard of Nvidia. Who didn't? I mean, who heard about Nvidia? Okay. Who heard about Nvidia outside of gaming? There are still some. Who heard about Nvidia outside of gaming and the financial performance of the stock? Okay, so there are still some people. Yes, we are doing a lot of things outside of gaming. Gaming is our DNA. It's our bread and butter still. It's more than 50% of our revenue. But we are doing a lot about visual rendering, called VR for virtual reality as well, but also visual rendering. All the graphic professional tools that people are using to do those amazing movies like that use CGI, it runs on Nvidia GPU as well. The other interesting area is data centers. Yes, people are putting GPUs, those graphic cards, into data centers because the power of compute of those GPUs is just immense. And it started by a couple of applications, but now more and more people realize the power of that. They need that power because there's an explosion of data available out there, and they need to process the data. Every process needs to happen more and more faster. Executives tend to ask to their developers to make solutions that are real time. They want to touch their customers, they want to touch their process as fast as possible in order to extract as much value as possible. And this is something, this is a business that grows 100% a year. So it's really booming actually. And the other one is self-driving cars. Self-driving cars, it's pretty fun. It's definitely an AI-driven, artificial intelligence-driven case. And we decided to go into that field because that was a challenge that requires AI from A to Z, and we wanted to be involved in all the steps of the project to understand it better. We think that sometimes that car makers may not have the necessary knowledge about AI and deep learning to assemble that by themselves, and so we decided to jump on it. And we have very interesting and cool solution. So today I will give a couple of words about why NVIDIA GPUs are rising into the enterprise data center. So a couple of data points here. There's a couple of revolutions that happened along the last 30 years. PC and internet, that was a big revolution. That drives a lot of economics behind that, a lot of change. The second change was the mobile and cloud era. I mean, the apparition of the smartphone, like a mobile computer where you can access and do a lot of different tasks. That was awesome. And now we are entering a next third big revolution driven by AI and IoT. So all those IoT sensors out there, they send and capture a lot of data about what you are doing, about different processes, and this amount of data needs heavy computation to be addressed. And AI is a science that needs a lot of data in order to be accurate and to deliver. So today everybody is using AI at least. Every time you talk to Alexa, you talk to your phone, okay, Google, or whatsoever, that's AI that works in the background. All right, let's move forward. So, why GPUs in the data center? And why GPU computing? So GPU computing, it's basically the combination of classical CPU that you can find on servers, plus a GPU used as an accelerator. And every part of the code that requires loops, that requires further iteration, or that could be parallelized, is basically handled by the GPU. And that fastens the overall process. So, if you see right now, more and more data are happening in our world. There's more and more compute cycles that are needed to perform huge and very important tasks for various researches and others. But the way the CPU performs, according to Moore's law, where every 18 months, basically the power of the processor was doubling because they were able to shrink the geometry on which the transistor was done, it's no more delivering anymore. So you can see here a plateau in terms of performances. And this is a logarithmic scale here. So you can see this plateau. So we have a plateau in terms of performance. On the other hand, the world needs more computing cycle. How do you address that? We decide, NVIDIA, that GPU was a fantastic accelerator to do that. And you can see here on this curve that we are taking the relay, and we are continuing that progression. That explains why more and more processes are moving to GPUs. That explains why MapD is adopting GPUs to run their high-speed database. Any question? So let's make it fun because we're not a huge crowd, so let's make it interactive. If you have any question at any time, feel free to
So what is the limitation of GPU computing?
What are the limitations of GPU computing? You can say that one is that not all applications could be easily ported from a CPU runtime to a GPU runtime. It needs to be changed a little bit. It needs to be adapted. Some are better to be accelerated than others, and so it takes time. When I joined the company, there was 150 applications that were GPU accelerated, and now there's more than 500 different applications that are GPU accelerated. So the world is really growing in that direction.
What about other technologies like ASICs and GPUs and FPGAs that are kind of also in that?
So yes, so that's a great question. So in the world of AI, let's say that GPUs represent for the training phase, which is a very intense, computively intense part of it, when you need to go through all the data set and parse the data set several times to train your neural net. That part use 99% of GPU. I mean, 99% of the time it uses GPUs. Now, other people are coming with some other solutions to create a chip that are really dedicated to that process. So that's the case of the Google CPU, or that's the case of FPGA, but they are still very new. And I would say their limitation is that the software ecosystem going along that is not as deployed and as rich as ours. So when we started the Nvidia GPU computing revolution, basically 10 years ago, we decided to open CUDA. CUDA is the programming language of the GPU. Okay, and you can program any GPUs. Even the GPU you are using for gaming, at some point of time, you can stop gaming and you can program and run some compute on top of it. That was a decision that our CEO took more than 10 years ago to make sure that anyone could start programming. And one of the factors that ignited this AI revolution was a student, Alex Krishniewski at the University of Toronto in 2012, and he decided to build a neural net to recognize imaging and bring that neural net to the ImageNet contest that he won by more than 10% against the traditional visual computing method, if you know. And this guy was able to do that because we opened the programming language of the GPU on gaming GPU. And so AI is a great part of it, but all the world of data science. So how many data scientists are here tonight? 1, 2, 3, 4. Great. So you're probably using a lot of those tools that have been used for the last 10 and 5 years that run on CPU. And you can see that more and more of them are using GPU to accelerate. So let me give you some couple of examples of what could be done when you accelerate data science with a GPU.
Data drives everything we do. In baseball, data like pitch speed, on-base percentages, and player biometrics are constantly being stockpiled to forecast outcomes. Now imagine pulling in seemingly extraneous variables like air quality, crowd tweets, and game-day traffic. If valuable correlations were found in disparate data sets like these, unprecedented predictions could be made not just in baseball, but across any industry. Global retailers could track and evaluate customer sentiment, optimizing their supply chains in real time. Healthcare scientists could study entire populations, predicting diseases in individual patients before the onset of a single symptom. Analyzing this much data is only possible with a new computing model using GPUs, making these examples a reality by correlating exabytes of siloed data in subseconds, drawing unforeseen connections only possible with AI-accelerated analytics. With GPU deep learning, you can unlock the limitless potential in your data, transforming your digital business into an AI enterprise. Get started with Nvidia.
All right. So yes, get started. If you want to start, go ahead. It's there, it's here, everything is in place. So what we have seen in our journey to accelerate data science and our accelerate AI is that there's a lot of different puzzles, and people are really addressing one part of this large cycle of data science, this large workflow. And so we wanted to help them. And basically, Nvidia and others created GoAI. So GoAI is the GPU Open Analytic Initiatives. And basically that defines the format when the data reside in the GPUs. in order to make sure that the various components of this analytic chain could talk the same language and avoid the copy back to the CPU to change the format between the various blocks and drives more adoptions. So today MapD is here, Anaconda, Shield.ai doing machine learning, BasicDB, another data warehouse, Gunrock, and Graph History that are graph database running on GPUs. They are all using the same GPU data frame. They are part of these GoAI consortiums, and they are driving the innovation forward with open source solutions. From ingestion to exploratory to feature engineering, machine learning, like in Shield.ai, and scoring or model export. The great thing about GPU is that they are everywhere. So you can find them everywhere. Volta is the latest architecture that we put outside. Volta is part of the Tesla family. The Tesla GPUs are the GPUs that goes into the data center in opposition to the GeForce GPU that are used in gaming. And Volta is the latest architecture. And you can find this architecture in every cloud today. Everybody has an instance that runs GPUs. You can find them from every computer makers. So the HP, the IBM, Lenovo, Dell, all of them provide several types of servers. And we are also making our own set of servers and workstation for AI and data science called DGX. Because we thought at some point that those guys are not going fast enough, and we create DGX, which is a lightweight GPUs that's very large, but that's the ultimate tool for data science and AI. The great thing as well is that we are building one architecture generation after generation, and this architecture serves different purposes. So we have our single GPUs here. So this is a classical PCIe card, like the one you find on your computer if you play games. This is the new form factors called SXM2. The big difference on this form factor is that we created a dedicated interconnect link called NVLink for those GPUs to talk together. Because PCIe was not evolving fast enough, and we needed more interconnect bandwidth between those GPUs. So that's the new form factor. The new form factor, SXM2 with NVLink. We are also doing some embedded solutions for robots and autonomous devices, others for self-driving cars, and we have our DGX family, the DGX1 in the data center and the DGX station. The algorithm is cool, but when you want a solution, when you want to work on a use case, you need to use a lot of software. And so what we decided is that we needed to use Docker containers in order to buy all the softwares to prepare the tool that match the hardware. And so with that mile of Docker containers, we basically make sure that the overall stack that you are using, that includes the OS, the drivers, the CUDA libraries, the accelerated deep learning frameworks, also solutions like MapD as well, are fully optimized and integrated, that we test the reliability and we test the performance. If you have tried, for example, to run TensorFlow on your own and to build it on your own, you may have seen that it's not that simple, that it may take time. And even if you have something that works, you're not sure that you are exploding and you are getting the full performance of the hardware. So we are doing that, and the great thing about the Nvidia GPU cloud is that this container that can run on all the platforms I mentioned before, that could be a single card, that could be a server, it could be a workstation, works also on the cloud. Okay, and so you can start to work on your own workload, scale it to the data center, and push it with the same environment to any cloud you want. Nvidia GPU cloud. How much time do you have?
A few more minutes.
Okay, great. So let me check this one. So I was up this one. And I want to talk about a couple of ways for you to try if you want to try. First of all, we have GTC. GTC is the GPU Technical Conference. It's an event that happens every year in California. It was so successful. It's really a developer conference for GPU users and lovers, and it lasts a full week. Last year we had 8,000 people attending this event. It's kind of massive. And it was so successful that we decided to export GTC. And last year we did one in China, we did one in Taiwan. We just finished one in Munich in Europe. there will be one in DC in October. So great place to be if you want to learn about GPUs. Great conference, people talking about their achievement, their learning, the latest discovery, all our partners developing solutions around GPU, which could be hardware solution or software solution are here to talk about what they are doing. There's another way to learn about that. It's the Deep Learning Institute. The Deep Learning Institute is a way for you guys to either start with AI. We provide the lesson about the essential and the fundamentals about AI and how to use that on different type of machines, but also GPU accelerated computing. So if you want to start about that, there's a great link. I invited you to look at it and find the catalog of courses. Yesterday we did an introduction to deep learning at Galvanize. That was pretty cool. And last thing, if you're really a software developers, go and join the Nvidia developer programs. We have a dedicated website for developers where we post a lot of code examples, we post a lot of technical blog posts, and that will allow you to understand a little bit more what we are doing. Now, a concrete example of what could be done about GPU. Aaron, I think you have the floor.
It's time. It's your time. Thanks, Alex.
In between, do you have any questions?
All right. This. Take this. All right. Okay. Thanks, Alex. So, now that I can tell you're all foaming at the mouth to get your hands on GPUs, I'm going to talk a little bit about one specific use case for GPUs. So we talk a lot about analytics in general. I'm going to talk specifically about how MapD has built an open source database, SQL database, from the ground up, specifically to run on top of GPUs instead of CPUs, and sort of how we take advantage of this GPU hardware to be able to accelerate SQL queries. As Alex said, we've got a small room here, so if anybody has any questions as I'm going through, don't be shy. I'm happy to go sort of off in the tangents that are most interesting for you all. A little bit about me. I run what's called the community for MapD, and that means, one, our open source project, so I care a lot about making sure we have a vibrant open source project and open source community. And then the second thing is helping onboard developers to use the platform, whether it's to embed in their own applications or to build dashboards and things on top using our immersed platform. So I'm here primarily to help new folks sort of learn about what MapD is, answer any questions y'all might have, and then help you get a first taste of how this can help with some of the challenges you might be facing, big data challenges, fast data challenges. So let me talk just for a second about why sort of we've gotten to the point we are and why MapD sort of is what our reason for being is. We spent maybe the last 20 years at least doing a good job of collecting data. It's been kind of this big push within every company. How can we get our hands on as much data as possible? How can we store that data? How can we manage those very large data sets? We've been pretty successful at that, but what we haven't been successful enough at, in my opinion, is making that data actionable. Anybody else wear a Fitbit on their arm? Anybody else seen how having that data at your fingertips actually changes the way you work, how it changes what you do during the day? It surprised me when I started having that data on my wrist, how it would actually change the way I operate because it gave me access to data I didn't have before. It made it so that that data, the number of steps I was taking, the amount of time I was sitting at my desk, was suddenly actionable to me. It was right there and available for me. And I think this is where we're at in terms of what we're doing with all that data we've spent decades collecting now, is we're starting to turn it into something that is actionable. And then I think the third step of that is making it predictive. Here again, we're all very familiar with what it means to have predictive data. This is, we've all been looking at weather forecasts for years now. But I think the important thing here now is how can we apply this notion of making things actionable, making them predictive, to these very large data sets that we've been collecting over time. And that's what I'm going to talk about in terms of how MapD can help. I think we have the technology that's in a unique position to be able to help people with very large data sets, make it actionable first and foremost, and working with GoAI and some of these other technology initiatives that Alex was talking about, make it predictive. So one more quick slide. well, maybe 2 quick slides before I get to the demo. I'm going to try and get to it as quickly as possible. Alex already talked about this. What's the difference between a GPU and a CPU? It's 2 things. It's the number of cores, and that's sort of what this primarily shows. It's also the speed of the memory, how quickly we can access it. And from the standpoint of a database, both of those things matter. Of course, we care about being able to access the data very quickly, but we can take SQL queries, break them up very effectively so that they run parallelized across the tens of thousands of cores of a GPU. And so typically we can run those SQL queries orders of magnitude faster than you would see on a typical CPU. Now, I doubt I'm going to get the question in this audience, but sometimes I'll get the question of, so why don't we just run everything on GPUs? Like, why would we even bother running anything on CPUs anymore? There's still some latency issues in terms of how fast each individual execution happens within a GPU compared to a CPU, and not everything can be parallelized. So there are some things that will still run faster on a CPU because they're designed to run better on a CPU, and there are things that will run faster on a GPU because they're designed to run faster on a GPU. And so what you really want then is a system that understands how to leverage both of these technologies to be maximally effective. And that's really where MapD comes in. I'll talk a little bit more about how we do things like memory management a little bit later, because those come into play when you start thinking about where am I going to put the data, how am I going to be able to access that data in the most effective way. Now, this is the last slide, I promise. This is just a really high-level overview of what is MapD. At its core, it is an open-source SQL database. So you can go to github.com/mapd. You'll see our entire database open source. You can compile it and run it to your heart's content. Apache 2, no restrictions. That database does everything you'd expect from a SQL database, and it's designed to run, as I said, on top of GPUs. Most of our users do not look at MapD as being their store of record. What they want is to be able to take the data out of their store of record, all this data that they've been collecting, as I said before, pull it into something like MapD, be able to use MapD then to run these really fast and efficient queries against it, and maybe update the data over time, sort of pulling new data in as it becomes available. But typically MapD, as I say, is not the store of record, so we have connectors over on the left-hand side to all the traditional databases that you'd expect. Use JDBC, ODBC, connect to any of those existing data stores to pull data into MapD. And then once it's in there, of course, as a data scientist, you're going to want to be able to connect to it using Python or connect to it using R. And on the right-hand side, you'll see, we've got the right connectors through a Thrift API to be able to connect into the database and do the manipulations that you need through data frames, etc. I'll talk a little bit more about that later as well. And then on top is the piece that we sell as a package to our customers. It includes a product called Immerse. This is the thing that enables you to build really fast and efficient dashboards of charts on top of that data. It understands how to take maximal effective use of that speedy database to create these really awesome, easy to produce charts, designed for data analysts basically, to be able to get their fingers on that data and make it actionable. So that's the piece at the top. When we sell this as a product, we bundle the Immerse product with the super fast database, and we sell that together into our customers. And of course, as I said, we have JDBC, ODBC drivers, so you could connect this to Tableau or other BI systems if you're more comfortable or more familiar. I'll talk a little bit about where that breaks down, because those BI systems aren't designed for the kind of scale or speed that we have, and so they have some limitations about what can be done if you choose a different system other than Immerse. But it's possible. We have customers that do it, especially for teams of data analysts that may be comfortable with a different front end. Okay, as promised. That is the quick intro. Now it's demo time. Let me just reload this to make sure I've got a nice connection. Yeah, it looks pretty good. All right. This is 12 billion with a B rows of data. It's shipping data from the Coast Guard, public data sets. Every ship in the US has to send a ping to the Coast Guard about every half hour telling them what kind of ship they are, what direction they're headed, where they came from, what's on the ship, a bunch of basic information about it. This is about 6 years, 7 years worth of that data. So as I say, 12 billion rows, that's a pretty big data set. It's one of the biggest public data sets we could find, actually. We've taken all of that data and put it into a MapD database running on top of 8 GPUs that are running in California. And what you're seeing here is the Immerse product I was talking about for building interfaces, building these kinds of dashboards with charts on top of that database. So I've got 4 charts here. I've got, on the left-hand side there, a scatter plot that shows all of the locations of the ships at any given time. I've got the different kinds of ships, I've got the length, and I've got the records by time. If I choose just one of the ship types, so maybe I just want to see the passenger ships, the system understands now to cross-filter across all of these different charts. So, the beauty of a live demo. Let me try reloading it one more time, just to make sure. Yeah, see, now I'm not connecting. Unable to connect. Try it one more time. No, that's okay. I'll come back to it. I've got one other demo here that I can show. This is a similarly large data set. It's 390 million tweets. It's the most recent 398 million tweets. It's all the tweets that include a geotag with the tweet. So what we've done is then mapped those tweets across a map. We've got, you can see, well, you can barely see it because it kind of cuts it off down here at the bottom. But we've got each of them color-coded by the different languages. So red is Portuguese, blue is English, orange is French. And then down the right-hand side, we've got all the most popular hashtags. So this is interesting because it's not our immersed product now. This is just us building a custom application on top of the MapD database. So this is all open source. You can go out and take a look at how we did it. You can see the different APIs that we use for making this. We have a MapD connector that connects to the database and also does all of the cross-filtering. We have a charting API that builds the chart at the bottom. And we have the rendering API, which renders the point map on top of the physical map. Now, this is where it starts to get interesting, because it's one of the real differentiators of MapD. We happen to be living and running on top of a GPU. So we take advantage of that GPU when it comes to doing this kind of rendering. We don't pass all 398 million rows back to the client and say, here, you deal with it. Instead, we pass that data right back into the GPU, have it render the point map for us, and then pass just a PNG back to the client. So what that means is two things. One, you have full fidelity of that data. All 392 million tweets are represented on that point map. Sometimes there's one point that has multiple tweets associated to it, because once you get into the Austin area, there's a lot of tweets on that one little pixel. But we're passing metadata, so you see all the data for that one pixel. If, for instance, I roll over any one of these points, I can actually see each individual tweet of those 390 million tweets on the map. So I'm not losing any of the fidelity of that data, and I'm still getting very, very fast response times. So for instance, if I say, just give me all the tweets in French, see how quickly that switched to all being orange now? What happened there was we actually went back to the server, did a brute force query across the entire database, all 400 million rows, several times, one for the hashtags on the right, one for the chart at the bottom, and one for the point cloud, the point map over top of the map. Each of those queries happened in about 150 to 200 milliseconds, even given the time, the fact that we're going out to California and coming back. So it's that speed of query and that ability to make that data feel interactive that changes the way people think about sort of large data problems, and why having this running on a GPU makes all the difference. We can create an environment where very large data sets are completely interactive. Now here's the interesting thing, the thing that surprised me at least. Like, I didn't expect, when I said show me all the French tweets, that there were so many French tweets. Like, I thought, okay, you're going to see some in France, you're going to see some in Montreal, you're going to see some, there are some places, but like, it turned out, and this is true for all the languages, by the way, but it turns out these languages are pretty heterogeneous. Like, people really speak these languages just about everywhere. And the weird thing is, if you notice, and you can probably see it on these screens, there's a bunch of little orange dots in the oceans. Can you see that? Yeah, so when first time I saw that, I was like, oh my God, there's a bunch of French people like stuck in the middle of the ocean, please, somebody go save them. I thought I had like solved some like massive international conspiracy. No, it turns out, oh, now look what I did. There you go. Turns out, there is an account that is tweeting, and I'll show you what it looks like. See if I can find one here. There it is. That is tweeting this sort of pseudo-random algorithm of codes out at a random location on Earth, anywhere on Earth. If you go to the guy's website, he actually decodes what it actually means. I don't know, it's completely, I don't recommend you go there. But the point was, like, this was a weird anomaly of the data. If I click on just his name, I can see just the tweets that are from him, right? And it's only 42,000 of the 400 million tweets. So a relatively small piece of the data. Not data that I necessarily would have been looking for, but data that I can stumble upon because I have the ability to be curious about the data. I have the ability to interact with the data. It's not something where I'm running a query, waiting hours for the result to come back, and it comes back to me in a static format. This is something that makes it highly interactive. If I can provide this kind of interactivity to a very large number of data analysts, I change the way they think about the capabilities of that data. It turns out, by the way, this guy doesn't just tweet in French, he actually tweets in every language. So if I take off the language filter, you can see it becomes a much more, a bit of a rainbow, I guess, across the globe. This guy's my hero. I hope he never stops tweeting, because I use this demo all the time. Someday I'm going to have to buy him a beer just to thank him for being this weird anomaly in the data set. And you know, this is not something that is terribly earth-shattering. It's not like I'm showing you something that is some great insight, but from a Twitter perspective, it gives us an interesting way to think about how we can interact with the data in a way that may not be prescribed when I sit down to think about what am I looking for today in this Twitter data set. I'm going to go back to the, everybody cross fingers. Come on, ships. No. I haven't responded yesterday. Can you ping the Slack channel?
Already.
You already did? Okay, we'll come back to it. The demos are designed to show you kind of the immersed interface, right? So this shows you kind of what it feels like to interact with the data. Matter of fact, maybe I'll just go to a different demo. When you get your instance of MapD Cloud up and running, I'll come back to that. So let me talk for just a second about a few of the things that make the MapD database, some of the sort of technical underpinnings of what makes the MapD database interesting, what makes it fast. Because even amongst GPU databases, we're the fastest. And it's because we've spent some time architecting ourselves to really take advantage of the uniqueness of what's in a GPU. We were talking earlier about what are the things what are the limitations of a GPU. One of the limitations is that GPU memory is super fast because it's built into the chip. So you cannot take a single chip and expand the memory as much as you want, like you can on a CPU. You can just continue to add additional memory to it, no problem. The GPU memory is built into the chip, which is great because it makes it super fast, and we take advantage of that speed. But that's also one of the limitations in that you have to be really smart about how you leverage and manage that GPU memory on the chip in order to make sure you're not just going to end up needing 1,000 NVIDIA chips. Sorry, Alex, I know you want me to sell 1,000 NVIDIA chips.
Go ahead.
Yet. I think it's worthwhile
Don't
for people
restrain yourself.
Yeah, it's important for people to think about, though. Like, well, that is one of the constraints that you have to think about, is that this memory is constrained. So what we do in MapD, when you bring the data in, we bring it into CPU memory first. So when you load your data, it's like loading it into a regular CPU in-memory database. It sits in CPU memory until you run your first query. When you run your first query, then we pull the columns you're querying against up into GPU memory. And we compress it along the way. So what that means is we're taking maximum advantage of what's in GPU memory. You only need the GPU memory for the columns you're querying against and for the data that you're actually querying. So even for a very large data set like the SHIPS database I was showing you before, the 12 billion rows, or that I tried to show you before, that very, very large database, we don't actually have all 12 billion rows, I think it's 30 columns in memory at once. We may have 4 or 5 of those columns in memory at any given time. And of course, what typically happens is, because we're having that sort of interactive experience with the data, we're typically making small changes to those queries and re-querying the same columns over and over again, making slight changes, right? And so that keeps those queries in GPU memory then and makes those queries really, really fast. And the delta for time of what it takes to bring a new column from CPU memory into GPU memory might be hundreds of milliseconds, but that's okay because the resulting queries after that are going to be so fast that that's the experience that you want. The experience you want is that interactive experience. The database does not require you to have a GPU. You can run MapD entirely on a CPU if you want to. That, of course, you're going to miss a few things if you only run on a CPU. You're going to miss the parallelism of the GPU, so your speed is going to be fast, but not blazing fast. And you won't have the rendering capabilities of the GPU, so you won't be able to do the rendering API and show those really nice point clouds or point maps in hundreds of milliseconds. So there's a few things you miss if you don't have a GPU, but again, smart memory management, designing the database from the ground up to take advantage of these technologies means that it's not required. Quick thing about GoAI, so I'm really glad you brought it up, Alex brought it up earlier. We're really excited about GoAI. It gives us the ability to, instead of passing data from a GPU in memory in the GPU down to CPU memory and then bringing it back up into GPU memory so that you can do training against it, and then taking those results and pushing them back and then bringing them back, gives us the ability to leave the data in GPU memory and just pass a pointer around. It's based on Apache Arrow, so those of you that are maybe familiar with that standard. This is a technology now that is becoming very prevalent in terms of how you manage data frames. We've created a GPU data frame, and you can go today and start building Jupyter notebooks using this technology. So we have a Python connector to MapD called PyMapD. There's also a connector for GDF, PyGDF. Take those two things. There's really good examples out there in those repos as well. So if you want to see how it's used, if you want to start to play with it yourself, highly recommend you go take a look at that. We did a demo at GTC earlier this year, actually, with Volkswagen, where we showed an end-to-end process for actually doing everything from the feature engineering inside MapD all the way through to doing the black box testing of the results back in MapD. So if you want to go take a look at that, all that code is out there as well. We have a Jupyter notebook for it. You can follow along to see how we connected to the database, how we ran XGBoost against it, and then how we took the results back in and viewed them. And I think maybe I have a slide on that. So this is similar to the slide Alex showed also on the pipeline. The reason I like to show this, though, is because I like to remind folks, I think sometimes, even for really great data scientists, they miss the fact that as data science becomes more prevalent within companies, it's not going to be a single person that's responsible for every step of this pipeline. There's actually going to be different people with different sort of capabilities, and they're going to need different tools along the way to be able to make that pipeline maximally effective. So when you start thinking about data preparation, doing your feature engineering, we believe a tool like MapD is going to make that a lot easier. Just being able to go in and visualize the data and get a sense of what's there, what things are correlated to each other, being able to build those dashboards and do that exploration that I was talking about, that curiosity is really important when you're in that phase of trying to understand what the features are that you're looking for. Then, of course, you're going to write the Python, you're going to write whatever script you want for doing the actual modeling. All that data is going to stay in the GPU. You're just going to do the training against the data as it sits. Then once you get the results, bringing those back into MapD to be able to see them, being able to do your black box testing, et cetera, against that data once you've actually done the prediction, then you still need that tool again, or we believe you're better off having a tool that gives you that kind of visual level of visual engagement. So this is what we were doing basically end-to-end with Volkswagen. And so don't know if I included the link here. I sure did. Oh, I'm so smart. This link down here, MapD demo, is where you can go to get the Jupyter notebook that we used in that example. So you can follow along. If you have any questions about it, let me know, or you can reach out through our community forum. And this is the GPU demo Docker. That's where you can go to see sort of the general purpose code of how do you actually get the GPU GDF, the GPU data frame. And how do you take advantage of it inside Python? Okay, before I go there,
Ship's working. I just got it.
If he says it's working, it must be working.
Are you using your phone for a hotspot?
No.
Oh.
Should I be?
Mine works.
I've done that before.
Yeah.
Okay, so 12 billion rows, I started this, right? 12 billion rows of data, different charts, blah, blah, blah. If I hit passenger, look at that, okay. So now each of those charts has done a brute force query back to the database against all 12 billion rows. There's no pre-indexing here, we haven't done anything to the data, it's all raw data. What comes back then is about a 200 millisecond query or 200 millisecond result for each of those charts, so it feels like it's very interactive. I can choose any of these additional other types and have it, again, do those really fast queries. Just to prove I don't have anything up my sleeve, I'll create a few of these. Let's just take the West Coast, and let's go just down the East Coast here. Just because there's no way I could have pre-indexed that. So that query took a little bit longer, probably 400 milliseconds, because of the complexity of those geographic or geometric designs. If I open up SQL logging here, oops. I'm going to put this down for a second so I can show this to you. So when I turn on logging now, and I'll get rid of this, you can see the actual queries themselves going back and forth to the client. So you can see, again, nothing on my sleeves. This is just SQL queries. There's nothing special about the queries themselves. You can see the details of the query, and you can also see the execution time. So 100 milliseconds, 149, 77 milliseconds. So these are very, very fast queries, very sort of generic queries in terms of the actual query that it's running. This means you could take this database, you could replace an existing SQL database that you have, and still be able to run the standard SQL queries that you have against it. They would just run a lot faster, and on a much larger, typically a much larger data set. Okay, so a couple more quick things. I'm good on time. I'm doing great. Geospatial. So one of the things that you've seen in the two demos that I showed was we're doing a lot of point scatter plots on top of maps. In both of those examples, all we've done is just had a column that was floats for longitude and a column of floats for latitude, and had the database not necessarily have to know that there was anything intelligent or anything particular about those two columns. With our version 4.0, which is coming out next week, we're actually adding native support for points, lines, and polygons. So this will give us the opportunity to have a whole new set of geospatial data sets and geospatial functions that will now be available. So we'll be reproducing those same demos now, and instead of using two different columns, we'll use a single column for points, and the result will still be the same. It'll still be fast, it'll still show, but now we'll be able to do things like, given this set of Starbucks coffee houses, tell me how many Starbucks are within 100 feet of a school, for instance. And being able to do those kinds of distance joins with two different data sets will be possible because the points themselves are native now, data types inside the database. I have a couple other examples that I'm not going to show here, but if you're interested, you can come up afterwards and I'll show them on my laptop, where we show how you can take and import those data types now, and how you can start to play with them, points, lines, and polygons, and the two functions that we have are distance and contains. As I say, all that's available starting next week for you to download and use. If you want early access to it, I can give you early access through our cloud, which I'll talk about in a second. So you just have to come up to me afterwards, and I'll help you get early access if you're interested. But we're really excited about this because geospatial has been this thing that's been kind of one of the unique factors of what's made MapD successful. And now we're starting to take it to that whole new level with these native data types and modules. We also formed a working group inside the open source, so these first data types are probably barely table stakes, maybe not even table stakes really, from a GIS perspective. So we're interested in working with GIS experts to figure out kind of what the roadmap is for what are the next things. We've got a working group now, has some GIS folks involved in it. So if you're interested in that, you can come join and help us out from an OSS perspective. Okay, so next steps. The two demos I showed are both available on our demos page, so you can go tonight, mapd.com/demos, and play with those to your heart's content. We also have maybe a dozen other demos out there, different kinds of data sets. There's an NBA data set that I like that just shows all the shots in every game for the last dozen years or so. These data sets are just fun to play with. So you can feel free to go play with demos. There's no, nothing you have to do there. You don't have to spin up any GPUs or anything. We're hosting them all for you. The second thing is MapD Cloud. So MapD Cloud is our basically MapD as a service. So if you go to mapd.cloud and give us your email address, we'll give you 14 days for free inside MapD as a service. It comes with 3 sample data sets and 3 dashboards that we've built. They are all the trees in New York City. There's a famous taxi rides data set for everybody that's kind of played with these large data sets in the past. And there's a flights data set, 7 million flights. You see sort of the beginning end point, the time of departure, the delay, all that information. So when you spin up MapD Cloud, you'll get access to those data sets. So you can play with it without, again, having any sort of commitment. You don't have to do anything with it. This is the taxi data set, so you could say, just give me, you know, let's see, just the rides at 2 p.m. Easy to play around with, easy to see what the functionality is, basically. And if you come into MapD Cloud, then you have the ability to add all the charts that you want. You can actually play with the data yourself. So you can create, you know, additional charts. You can feel free to create additional dashboards even. And you can upload your own data. So if you go to the data manager, you'll see the 3 data sets that come preloaded. So flights, trees, and taxi rides. If you click import data, you can import either from a local file if you have a CSV, if you know it's not that big, or if you have your data sitting in an S3 bucket, you can load it directly from the S3 bucket. We can accept CSV, we can accept zip CSV, we can accept GeoJSON, we can accept the Esri shapefiles as well. So any of those data types, easy to import, easy to get your data in and start playing with it. So I encourage you to go take a look at that, because that may be the easiest way. It's 14 days for free, so you can, you know, basically get a chance to play with MapD on us using our GPUs. Next option is our community edition. So if you say, yes, but I've got my own GPUs, or I want to run this in my AWS cloud, or I want to run it on Azure or any of the other clouds, you can download our package, which is our community edition. It's basically everything I've shown you tonight packaged into a package that's for non-commercial use. So we want you to come play with it, we want you to kick the tires, we want you to evaluate it. And then if you decide this is something for you, of course, then you can come back and get a commercial license on the product. And if you have any questions about MapD as you're going through it on any of the different options, whether you're using the open source, whether you're using our cloud, or whether you're using the community edition, I encourage you to go to community.mapd.cloud or .com. Our engineers are really actively involved in that community, so you'll have a chance to get in there and talk to the experts if you have any questions. And with that, this is my very professional advertisement for MapD Cloud. With that, I can take any questions, or if you don't ask questions, then I'm going to sing. So
you mentioned that on the memory graph that a lot of the data is cached. How does that work with multiple users in the same database at the same time?
yeah, so the database itself just looks at queries, doesn't necessarily look at individual users, so there's no way to prioritize one user over another, right? So in this case, it just looks to see, is the query you're running, does it have the data that I need in GPU memory or not? If not, I'll pull it up. If I need to push some old data out that hasn't been used, I'll push the old data out. So it's possible to get into a scenario where things are running slowly only because you're swapping data so much, right? We can work with you to figure out whether that's happening and to help you optimize for that. But for the most part, our customers typically, even when they have multiple users hitting the same database, they're typically all looking at basically the same kinds of data, even looking at the same dashboard, right? Just doing different queries on that same dashboard. So it's typically not a very, it's not a problem we run into very often, but it's one we can optimize for if it's there. One thing I didn't talk about, sorry, just one quick thing, because it applies to that a little bit. One other smart thing that we do, every time a SQL query comes in, we actually use LLVM, for anybody that's familiar with low-level virtual machine, to compile the SQL query down before we pass it off to the database. This is better for two reasons. One, it means we're not doing interpretive, we're using a compiled version of the SQL query. It makes it much, much faster. And second is, it means we can compile and optimize it for specific platforms. So we can compile and optimize it for a platform where we know we have massive parallelism, like a GPU, or we can compile it to run even maximally efficient on a CPU. And so that is just another way that we're helping to speed up. Every inch of this process is designed for speed, designed to go as fast as possible. And so, that compile process is one that, just from a technical perspective, really sets us apart. Yeah?
Earlier you said like you keep switching columns, right?
Yeah.
So have you run into a scenario where you need all the columns into your GPU and running into memory issues?
Sure. And there's always a case where you'll run out of memory, right? And we can write a query that will make any database run out of memory. Like, that's not the problem. So two options there. One is you can tell MapD to default back to just using CPU. So you can say, if the query is too big, just do your very best on a CPU, knowing that query will just take longer. Or, again, we can work with you to make sure that we're doing a better job of optimizing the number of cards you need, the amount of memory you need, to be able to run the kinds of queries you're looking to run. Anytime we've worked with a customer where they said, this is the query that I need to optimize for, like sort of the number one, most important query, that makes it easy for us to help do the sizing, help them understand kind of what the limitations are then of, based on their specific data type. The data sets are always so unique, right? There's never two that are exactly alike. So, like I said, if you want to sit down and talk about it a little bit more, we'd love to do it. But there's no silver bullet there. At some point, you will run out of memory.
And you can also run distributed across multiple machines. You can scale out as well. I don't know if you spoke specifically to scale out.
No, that's exactly right. Yeah. So we have customers that are running on hundreds of billions of rows of data, which means you have to not just run with multiple cards in a box, but multiple boxes with multiple cards in multiple boxes. So these systems can get large and still maintain the performance level that we were showing here, running 12 billion on an 8-card box. Other questions?
What kind of SQL database do you support?
What kind of SQL?
Database do you support?
So we're not SQL 92 yet, but we're close. And with 4.0, we're getting even closer. So if you run into a corner case where you say, this is the SQL query that I need to run and it's not working, because it's an open source project, you can help us prioritize the right set of queries that are going to go into the next release. So we work with the community directly on those kinds of things, and we will get to SQL 92 compliance at some point. Honestly, it's probably not a top priority for us right now, just because I think we've got a lot of other things that we'd rather focus on. Even some of the rendering and geospatial stuff is actually more interesting to us at this stage. But as part of an open source community, come help us. If you find the corner case that you really need, we'd love to work with you on it.
How about like the graph database support?
No, this is a conscious choice. We've really focused on columnar SQL database as being the problem we're trying to solve. And of course, there are a lot of other kinds of databases, a lot of other ways of thinking about structuring and organizing data. We've purposely said those are kind of out of bounds for us right now because we think that this problem is, frankly, a problem that's hard to solve and that we want to focus on getting right. So here again, if you've got a use case and you'd love to sit down and sort of kick it around with our technical folks, we'd love to do that because we just like thinking about the kinds of hard problems that may be coming in the future, or there may be even a way we could work together on something today. But just in general, when people say, yes, but can you do anything that's kind of outside of our little circle, we're pretty quick to say no, only because we don't want to set any false expectations. And as I said, I honestly think that the space that we have right now is such an interesting space that it's taking all of our days and nights to be successful there.
Is there any size limit for the dataset in the GPU Cloud Community Edition?
Yeah, that's a great question. So in MapD Cloud, so the MapD Cloud instances that you can create today are single GPU instances. So I think we have a rough estimate of 100 million rows or something like that is kind of the upper bound of what you can do inside MapD Cloud. We also will spin up custom MapD Cloud instances which can run with multiple cards in a box and multiple boxes. So if you say, yes, but I have a much larger data set and I still want to use your cloud, come talk to us because we do have a couple of customers that are using this with larger data sets, but the one that you can self-provision just by going out and spinning something up is a single GPU instance. Like I say, for probably 90% of folks when they first get started, it's not a question of running the 100 billion row data set to start with. Get the 50 million row data set in and make it sure it does what you want, and then we'll talk about being able to scale up from there. So we will have self-provisioned multi-card boxes soon on MapD Cloud. But for today, it's a single user.
Do you find that the customers tend to like normalize data or something like that to get better performance?
It's interesting. So there's two reactions that our customers have. One is they're often surprised how little ETL they have to do on the data because they're so used to, frankly, having to optimize the hell out of their data and put in all the extra columns they need for doing indexing and everything else, right? So they typically do a lot of work ahead of time to be able to make the database fast, which they don't have to do anymore. So right now, you just take and put all your data in there and run the brute force queries. They will run more than fast enough. Don't worry about that. And beyond that, I don't think that there's there's nothing special about bringing the data into our database versus another database. So the ingestion process is pretty straightforward. I think if you start playing with the version we have in the cloud, or we can show you how to ingest data through the back end. So if you want to get it up and running in your own cloud, you can use our MapDQL interface for loading as much data as you want directly into the database. You can also use PyMapD and load the data frame into the database if that's how you want to do it. So there's a lot of different ways to do it, and I think most of those ways are kind of standard. Like there's nothing special about it from a MapD perspective. The only difference is you probably will have to do less sort of ETL and prep work because the database is so fast you just don't do that. Okay, I think that my time is up. Thanks everybody. I'll stick around if you have any questions or you want to see anything else that maybe I didn't show but alluded to.